On this episode of TQA Weekly, I answered a question of how much bandwidth a graphics card has available to it, as well as what is actually bottlenecking your game. My name is Steve Smith, this is TQA Weekly, and if ever you have any questions, comments, suggestions for other topics, you can do it by emailing me at ask@tqaweekly.com. You can go to my website, tqaweekly.com, where you can email me directly, go to the other past episodes as well as this one, and interact with others on each of the specific topics of those days. You can go to the subscribe page where you can find other ways of communicating with me via social networking, as well as other ways of subscribing to this show. And of course, while you're there, you can click the Support Us link to find other ways of supporting my show. Today's question is, how much bandwidth does a modern graphics card really have access to? And what is really bottlenecking your video game on your computer? And I'll explain to you how to tune your computer and why that might not be enough anyway. So first of all, PCI Express buses usually generate the amount of data being transferred to a graphics card as being something calculated in the gigatransfers per second. 1 gigatransfer is equal to 100 megabytes per second. So let's start. PCI Express version 1 has a data transfer rate of 2.5 gigatransfers or 2.5 gigabits per lane. As we all know, graphics card usually has 16 lanes and only theoretically connects to this, so we're theoretically calculating the speed. So for those that actually get 16 lanes, this means 32 gigabits per second, or 4 gigabytes of data transferred every single second. So for those who do not know, that is an entire DVD per second. So every minute, 60 DVDs of data is being transferred or being shoved down the throat, if you prefer, of the graphics card. The PCI Express version 2, what we normally know as the unbottleneckable speed, would be 5 gigatransfers per second or 4 gigabits per lane, which comes out to 64 gigabits per second or 8 gigabytes every second for data be transferred, or 2 DVDs per second being shoved down the throat of your graphics card. The current generation PCI Express version 3.0 has a transfer rate of 8 gigatransfers per second. That comes out to 15.754 gigabits per second per lane, or 126.032 gigabits per second, which comes out to 15.754 gigabytes per second, or just about 4 DVDs of movies being shoved down its throat. And in the future, PCI Express version 4 will have 16 gigatransfers per second, or 15.754 gigabits per second per lane, which comes out to 252.064 gigabits or 31.508 gigabytes per second available. You can take a graphics card that is PCI Express Generation 3 with today's games, by the way, this is fact, under 1080p, by the way. So if you're running your game at 1080p, you can take your 3rd generation graphics card, shove it on a PCI Express Generation 2 board, and you theoretically should not bottleneck it as long as you have the minimum required specifications for games. So for AAA titles, that is theoretically quad-core processor, 8 gigs of RAM minimum. I would suggest 16, but going from 16 to 32 doesn't really give you a benefit unless you edit videos and stuff. And of course, having a VRAM of 2 or more gigabytes available, which would theoretically allow you to play just about every current game out there on the market, as well as all previous games. Now, knowing all this and having Windows 7 or Windows 8 means that you should not have an issue. But the issue with gaming currently is the number of draw calls being done for the graphics card being queried at the CPU, which is a problem for DirectX 11 and all other preceding DirectXs. And DirectX, by the way, is a programming API for video games that allows developers to actually code stuff. So we can blame Microsoft for this because they're the one who made DirectX. And here's the thing. To fix that, you're gonna need a lot of different changes to your system. So one, your system will have to support UEFI, will have to have a graphics card that can support DirectX 12, will have to have 8 to 16 gigs of RAM and a quad-core processor in order to be able to play all the games for this fix to work, and only then will whatever work the developer do have anything to do with it. So you have to have a UEFI motherboard, and then when you get Windows 7 or 8, when Windows 10 comes out, upgrade to Windows 10 so you can take advantage of DirectX 12, and hopefully, we're crossing our fingers, the developers out there will actually make a patch that makes the game playable in DirectX 12. Yes, I just said it. The solution to this entire thing is upgrade a computer to be able to play DirectX 12 and not be able to experience anything unless the developer does any work out of it. So it is quite possible that a bunch of games will not be supported by DirectX 12 and will not benefit from the draw calls that actually makes our computer system lag. Especially with games like Assassin's Creed Unity, where the majority of the problem is literally we want the big massive worlds, but they don't code it correctly because they try to generate the entire planet in one shot as opposed to the immediate realm around you. Hopefully you learned something from this. If you did, tell me what you learned down below. Like this episode, dislike it, tell me why. You can leave your comments, suggestions for topics down below, as well as other questions to other topics. Trust me, I don't mind. I'll read them all. And of course, you can always go to tqaweekly.com where you can use a contact form to email me directly, interact with others on past episodes I have done as well as this one. Go to the subscribe page to find me on social networking as well as other ways of subscribing to my show. And of course, you can always go to the support us page where you can see the wish list and other ways of actually helping me out with this show. Have a great day and goodbye.